we're super happy to welcome you with our team. So my name is Silva. I'm going to be your host for tonight, and along with the team, Sasha, Douglas, Yann, and Truni, we're really excited to welcome you for this very first data science demo day in Tokyo. So before we kick things off with the projects and as well as a little talk from our teacher extraordinaire, Yann, I would like to, first of all, give a few thanks. And the very first people that we want to thank are the Impact Hub people. So why Impact Hub? Well, for those of you who do not know, Le Wagon is located in a really cool co-working space in Tokyo, very specifically in Meguro. And this co-working space is called Impact Hub Tokyo. We've been at Impact Hub for the past 4 years, and over the past 4 years, they have been amazing with us. They've been dealing with us and being really nice. And as I was saying, Impact Hub is also a co-working space. More specifically, a co-working space geared towards social entrepreneurs. So if you have an entrepreneurial project, and specifically a social entrepreneurial project, you may want to check out the space, and you will have a chance to work alongside with us. The second people that I'd like to welcome and thank tonight are our amazing teaching team. We've had a really cool staff for the whole bootcamp. We had Yann, who's going to be speaking right after me. We also have another Yann who's part of our team, Yann Klein. And I would like to specifically thank as well Sébastien, Fabien, Xan, Arnaud, and Rico, who joined us at the end of the bootcamp. And obviously, last but not least, Truni, who did an incredible job running this bootcamp from start to finish. As I was saying, this is the very first data science demo day in Tokyo. We launched that program worldwide a little over 6 months ago. So I believe it started in London. And tonight, this is the very first demo day in Tokyo for data science program. A few facts about this bootcamp. There are a couple of really exciting facts. First of all, we had actually 2 students joining us remotely. One of them is going to be pitching tonight. She's smiling already, all stressed. Samiri is going to be pitching, joining us from Australia. And we had someone joining from Hiroshima, Jin, who's also on the call tonight. The second super interesting fact is that for this very first data science bootcamp, we actually had more women than men. And as you know, we're really pushing towards that. We're trying hard to bring in more women in tech and in data science. And so for this bootcamp, we had 4 women versus only 2 lone guys. What you're going to be seeing tonight are the projects that our students delivered during the last 2 weeks of the bootcamp. So the bootcamp itself lasts for 9 weeks. And during those 9 weeks, our students learned quite a lot. They went through Python basics. So for those of you who know Python, I guess that sounds really familiar. And then they moved on to data analysis, machine learning, deep learning, and something that's really important, and I believe that Yann is going to talk a little bit about it as well, is how to put all of this in production. So Le Wagon is a very hands-on bootcamp, and everything that we teach, we want our students to be able to bring it into their next career. And so we have a very business-oriented approach. Starting from the projects, we want the projects that they pitch and work on to deal with actual issues. After the bootcamp, our students are going to be moving forward with their career. Some of them will become data analysts, some of them will become data engineer, some of them will become junior data scientists. As I was saying, those projects, the project that you're going to be seeing tonight have been developed in only 2 weeks. Just keep that in mind. And they've been developed as teams of 3 people. That's pretty much it for my introduction. The next person I'd like to introduce is Yann, who's working as a machine learning engineer at a company in Tokyo, and who we had the chance to have as a teacher for our deep learning week here. So without further ado, I'd like to welcome Yann for his quick intro talk. Welcome, Yann.
Thank you so much. Thank you, guys. So I was thinking about what I could say for this speech, and especially thinking of you guys. And I wanted to start by something that would represent what you guys students are doing in Le Wagon. And I found this quote from Nelson Mandela. There is no passion to be found. There is no passion to be found playing small. And you guys are challenging your life and coming here for 9 weeks, and you are learning new things. And I think this is exactly what you are not doing playing small, you are actually playing big. And I wish all my customers would think in the same way. I was involved in about 25 data-related projects in the last few years, and I saw companies struggling a lot in values from their data. And they keep trying, but it's hard. And they keep trying for a reason. You can see now the world is changing faster than ever. And especially this year, we had coronavirus. It's changed everything. But it was actually a good opportunity for some companies, but other companies are struggling to thrive in this environment. And you can see that the companies that are actually getting advantage of the situations are the companies that are actually using their data. And it's not a coincidence if the biggest companies in the world, they're actually the one that possess the bigger amount of data. And they are also the one that can process those data. So they have those two characteristics. And this is for a good reason. Data can help us to navigate this storm of changing, continuous changing, and this storm of crises and cycles. And organization and individuals which consider this data as an asset are actually the one who are thriving in this economy. But if you look at those companies, their product is not data or AI. Their products are like search engines or e-commerce platforms or advertising platforms. And the data are something that they are using to actually understand better their customers, to understand faster the trends and to adapt. So this skill is very important. And actually those things are accessible to any company if they want, because data are everywhere. You can see you have texts, videos, sensors data, it's everywhere. But it requires specific skills. And if you have the right skill, it can make a difference. But if you don't have, you can actually create new storms. And in my opinion, this is what Le Wagon Bootcamp is doing. During 9 weeks, those 9 intensive weeks, the students get this superpower of manipulating and understanding data. And so in this batch, 509, 6 students, so 3 here and 3 remote, you guys tirelessly coded your data processing pipelines and your models. And finally, you walk through the path to taming your own data. And as it was mentioned before, we can see that you guys, 6 students, you have all different backgrounds, some not related at all to IT things, 6 nationalities, sorry. And you decided to play big. So I remember well, I met you a Friday. It was the last day of already tiring week. And you share with me your kind of concern and anxiousness about playing with neural networks. And I understand, I mean, neural networks is already scary as a word. And some of you guys didn't even know how to code once before. So I was also kind of anxious about this. And then the Monday, we started to actually learn deep learning. And we started by 1.5 hours of lecture. And then all the day until 6 p.m., you actually practice. And the amazing point is that actually everybody was able to implement their own model and train their model. So you guys, by having this short amount of time, you could actually train your own models. And this is one of the good points of Le Wagon. Le Wagon method is about taking some very complicated concepts, breaking down into small pieces that individually can be understood. And this is the specific point that I really enjoyed as a teacher. And I think this brings a real value to you as a student for doing your job. And maybe you will be data scientist or not, product manager. And what you learned in Le Wagon in those 9 weeks are very important because this new economy is valuing this type of knowledge. So tonight, you guys are going to show what you developed in 2 weeks. 2 weeks ago, you identified a specific pain point and you developed, built a prototype around these pain points. And what I can say on the one specific point I was very impressed is that you use the technology not for the technology, because it's kind of common to have this situation where people, they are pushing the technology itself, but you focused on the pain points and you focused on delivering something useful for the end user. And in my opinion, this is one of the most important points in this industry. We have many people, many researchers working on those topics, and they are very smart and they are making very powerful models. But what we need also is people who can combine their own knowledge, their own experience with those technologies, and to bring value to the end user. And I hope that everybody will enjoy this demo night as much as I enjoyed being your teacher. Thank you.
Amazing, thank you so much, Yann. I think Yann deserves a big round of applause. That was a great pep talk. I hope everybody is super excited about this. Miri looks excited. Miri, you're ready to go? So yeah, without further ado, I'm going to introduce our very, very first project. We have 2 pitches for tonight, 2 pitches, and the very first one is FallGuys, and Miri is going to pitch from Melbourne. And there is a little surprise for this project, but I won't spoil it. So Miri, you can go. The floor is yours.
Hi, I am Miriana, and with my team, I've been working to deliver a solution to a problem that we believe affects many of us, either directly or indirectly. And particularly, we focused on a problem that affects one particular demographic group, the elderly in our society. And the frequent and the sad occasion for them is that they fall and they do not get immediate assistance that they need. So I would like to introduce you to the fall detector. As you know, for obvious reasons, elderly fall more frequently than the other groups. But not just that, they also experience more gravid and bigger consequences, physical or emotional. And some studies show that 50% of nursing home residents fall at least once a year. Now, as I said, they experience more severe artful consequences, physical or emotional. This is why timely assistance is critical, because if the fall remains unnoticed and they do not get the assistance that they need, the consequences can be fatal. And wouldn't it be nice that you know that your grandma was getting the assistance immediately after the fall, or that she doesn't fear leaving the house without knowing that someone would be there straight away if she had fallen? Well, we thought with more nursing homes being built to facilitate the growing elderly population, as you can see here, this is Japanese elderly population. And if I just scroll this down, you will see astonishing percentage of 30% of Japan's population is over 65. So we thought, why don't we do something, provide a technological solution that relies on already available resources and do some good. What we built can provide the elderly with comfort to live their best lives, and that carers and caregiving businesses an opportunity to do their jobs, the caregiving jobs, more efficiently. So together with ZTO, we have developed this solution, and the final goal of our project was to integrate this powerful algorithm or model in a front-end platform like a mobile application. So we work with them to collect the data, adapt it, decide on the best model, and decide on what would be the best way to deploy this model. So I'll walk you through some of the steps where we will show how we went about it. And finally, I will show you how the model actually works. So why smartphones? Well, we needed real-time data from our user base, which is the elderly, and the smartphones appear to be the optimal medium. Why? Because they're widely spread, they're cost-effective, and everyone seems to have one. But most importantly, they have inbuilt sensors that can facilitate what we are aiming to achieve. So you may not know this, but your smartphones have sensors, and quite sophisticated ones. And in particular, they have an accelerometer, a sensor that can detect your motion and continuously collect data on your phone's position in a 3D space. These three axes show that how the data is being collected. So X, Y, and Z show what's the position of your phone in your pocket or in your hand. Now, our partner, ZTO, has a similar product of what we were trying to achieve, and they are detecting users' physical activities on using the smartphone sensor data, such as climbing stairs, running, walking. But they've also had a sample set of fall events, and this was critical for our project. So when we looked at our data, we analyzed it, and we understood that among all these categories, we needed a powerful model that can distinguish among many different activities, but most importantly, conclude if any of these activities were interrupted by a fall. So we decided to go with a deep learning model because they can learn on their own, which means that if we show them how the pattern of falling looks like, we show them the sensor data of a fall, they will be able to recognize it in the future. So one of those deep learning models that we settled on was the long short-term memory model, which is a type of a deep learning model that can process entire sequences of data at the same time, and it's very appropriate for time series, which is the structure of our data and our data set. But also very important and maybe a bit technical, LSTM maintains information in the memory over time, which means that it takes into account past data. And for us, that was relevant because it was really important on what happens before the fall, so our model can learn that the fall has occurred. And in the evaluation stage, when we tested our model, this model did perform the best. So what data scientists usually do, they do train the model, but they train the model only on the portion of the data set. We usually split 80-20 ratio, and we model the model on the bigger data set. We optimize it and make it as perfect as we can, and then we test that model on the 20% of the data to see if the model actually returns what was expected on the data that it has never seen. So our metric was based on how many times would our model identify the fall and how many times would it misinterpret other activities as a fall. And after some optimization, the results we got that were 100% of the time our model would detect the actual fall as a fall, but 17% of the time it would identify other activities as a fall. So one really important thing to note is that all the scoring depends on the data that you have. Our falling data set was a sample, and it comes without saying that the more data we have, the model will be more robust. But the point that I'm trying to make here is that those 100% show that we have built a powerful model, powerful enough to detect 100% of falls, which results in high confidence in our end product, which means that whenever a person falls or is using our end product, they can be certain that the notification will be sent after a fall has occurred. So I'll quickly show you what the data stream of this sensor data looks like when a person is conducting different activities. And finally, we'll be able to see what sensor data looks like when the fall occurs. This is something that the model reads and learns from when it's trying to predict or identify the fall in the end. So you can see the labeling changes as the sensor data changes, and you can see that the different activities have different patterns. Now let's see what happens when a person falls. And there it is. and you can see that our model has identified a fall and have sent a notification. Now, this is our final product, but what it lacks is the front end. And our model is designed to have some kind of front end, but it can also be integrated in many various systems if only adjusted. So our aim is to create a smartphone mobile application, but as I said, it can work in any environment. Okay. And finally, I would like to thank my team, Jin and Sven, who have contributed massively to this project, and for all the emotional support from the TA and all the knowledge. And I would like to invite you all to ask questions. If I have missed anything, or if you would like to know more, feel free to ask. Or visit our webpage, which is live, visit our frequently asked questions, or send a message in the chat, and we'll be happy to answer any questions that you might have. Thank you.
We're going to be moving to our second presentation. I believe Aaron is getting ready. So without further ado, let's invite Aaron on stage with Mixes. Let's welcome Aaron.
Hi, I'm Aaron, and I'm going to talk to you guys about Mixes. So some of you may know I am also a musician as well as a budding data scientist. And say, for example, I want to learn a new song or something like this. I would pick up my guitar, I would play the track, and I would start practicing and picking up the parts. However, this sometimes comes with quite a bit of difficulties. Yeah, a lot of songs have quite a lot going on, and it can be really hard to clearly hear certain instruments, and quite hard to focus on specific parts. For example, if a trumpet player is playing the same frequency range as the guitarist, it can be really hard to really hear exactly what's going on there. So with Mixes, what we are planning to do, and what we have hopefully done successfully for you guys, is bring clarity to that practice. We want to give you the ability to listen to just your instrument, or focus specifically on what you want to focus on. Maybe you're a drummer and you just want to groove with just the bass and the drums, and allow you to have really productive, efficient practice, with also the ability to be able to create really good quality backing tracks nice and quickly that you can practice to. And we've done this for you guys today and during this project, and built a little web application that you can do this simple task with. Well, not so simple. And it looks a little something like this. Very simple UI that we've built for you guys. And you can simply go to YouTube and grab a random song that we have chosen here, paste in the link, and then you can just simply click the separate button, and it would start to do the magic in the background. So while it does its magic, I'm going to talk to you a little bit more about what it's actually doing and how it's doing this and how we've constructed it. So we are using machine learning to do audio separation. And this is a fairly complex task because on a base level, audio data does look quite complex. This is an example of a song. This is a visual representation of it. Left to right is the beginning to end, and top to bottom is the high and the low frequencies. And if I asked you to tell me where the drums are in that, you'd probably find that a little bit difficult. Even I do after working on this project. However, we've built a machine learning, deep learning model that can take the vocals out of it, can separate the drums, it can separate the bass. And the reason, the ways we kind of did this is our first step, obviously, we had to get a data set. So we gathered a data set of around 300 or so songs that have been set up to have the full audio mix, which is what you normally listen to on the radio, as well as having what are called the stems. And the stems are individual instruments, so just the vocals, just the bass, just the drums. So we could then apply that to a deep learning model and allow that learning model to learn the subtle features of each stem instrument and compare it to the full waveform of the full track, and eventually be able to pull those from whole tracks and return that to us. Then we built a system that could take the outputs from those models, convert that into an audio form so we can listen to it. And we then put together a nice, easy, interactive player for you guys to use, so you can use those tracks in any way that you want. So before I kind of go into showing you the website, I just kind of wanted to talk through a couple of different challenges that we had that I thought would be interesting to share with you, some of the technical complexities of what we were doing. So for this to actually work, we had to do quite a bit to the songs first before the models could actually do anything. For example, we're very well attuned to listening to music. We have ears that are perfectly designed to do that. However, a computer can't do that. A computer works with numbers. So we had to convert the song into numbers and basically make the song into a list of numbers. So that meant that the model actually was also outputting a list of numbers. So this here is actually a vocal track after the model has outputted it. And when we were looking into the different models we were going to use and comparing them, our first question was, well, how do we compare that list of numbers to this list of numbers and decide which one is actually better? Luckily, with our data set, we do actually have the raw stems. So we were able to take the actual stem of the vocal track, the original one, and compare it to the model's vocal track using some mathematical processes that can do that for us and come up with what is called the signal to distortion ratio, which is basically the signal, which is what we like to hear in the actual audio, and the distortion is the weird artifacts and things that just don't sound so pleasant. So the bigger the number, the better. So we were comparing a lot of models using this, and we also double checked it ourselves by listening to the outputs once we converted it to audio. And one of the main assessments as well was speed. We don't want to have our model taking 10 minutes to split a 3-minute long song. And we want you guys to have access to it as soon as you can, but with a reasonable amount of quality. Another interesting challenge for us as well was actually, how do we get this to you to be able to use? We've been learning a lot about data science during this time, how to manipulate data sets, build models, train them, but we had to spend the time during this project to be able to actually deliver that to you. So we spent some time learning some front-end technologies as well, deploying it, which was an interesting task because this model actually needs quite a bit of power. So we had to enlist the aid of some cloud computing for us to do that. So that's kind of how we built it and some of the challenges. Now I want to actually show you what we did. So while I've been talking, it's been separating the track for you. And we have this nice, neat little player that you can interact with, and we can have a listen. So as you can hear, hopefully everybody can hear that all fine. Please double check if we can. That's the track that everybody wants to listen to. But say, for example, you're a drummer and you want to learn the drum track. So let's just listen to the drums. Boom. All right, so I've been learning that drum track. I've really got that groove down because I could listen to it purely on its own. So now I just want to practice without the drums there so I can make sure I'm locking in with the band. Okay. Are you ready for a brand new beat? Summer's here. Great, cool. I've done my practice. It's sounding great. Now my buddy wants to make sure that she's got the vocals down. So let's have a listen to how Martha does it. And the time right for dancing in the street. Cool, she's had plenty of time to listen to that. So now it's time for a little bit of a karaoke session. Great, so that's really simple to use. If you wanted to listen to the brass section, you can also just solo that specific track and listen to that. Very easy, intuitive, and you guys could potentially have a play with that on our website that's live at the moment. Please don't overload it just yet until we finish the presentation though. So yeah, that's a rough overview of what we've done so far. So what I'd like to do next is thank everybody on the team. Jerry on the right there, Aishu on the left. My name is Aaron. I'd also love to thank all of the teachers that have been working with us so well over the last 9 weeks so we could deliver this to you. And yeah, any questions?